Good morning. Let us see today Maxwell's relationship. What are Maxwell relationships? How it is easily derived. From the fundamental thermodynamic equations. For example, first law of thermodynamics, second law of thermodynamics, H equal to E plus PV, G equal to H minus PS, A equal to. There are 5 equations are required. There are 5 fundamental equations are required to get the Maxwell relationship very easily. You can derive one of the derivation all of them are similar. That is very important. You please listen the lecture very carefully. You will be able to derive very easily the Maxwell relationships. Okay, first let us know what are we know. We know according to first law of thermodynamics, Q equal to E plus work done. That is, heat is supplied to a system. It gives internal energy, therefore it is the internal energy changes and it also does work. Therefore the heat supply is converted into internal energy and also it does some work, pressure volume work. Therefore work. For infinite small heat supply, dQ equal to dE plus PdV. This is pressure volume work done. And according to second law of thermodynamics, we know the change in entropy equal to heat supply divided by temperature. At that temperature, therefore dQ by dt. Therefore, on cross multiplying, what you will get dQ equal to. Therefore, you can substitute dQ in this expression. dQ in the dTs. Therefore, dE equal to TTS minus PdV. Okay, this is very important expression. There are 4. Okay, now use H equal to E plus PV. You know this relation. You are studying in your plus 2 also on differentiating, where H is the heat content, where E is the internal energy, and pressure is the volume of the system, pressure of the system and volume of the system. On differentiating this equation, dH equal to dE plus UV formula. You apply UV formula. First P constant dV and then E constant differentiate dP. Therefore, next you see you have derived already dE. You substitute in this expression dE dTs minus PdV. Therefore, plus PdV. It will get cancelled plus dDP. This is dH. Now we have derived dE and dH. These are very important expressions. Then G equal to H minus PS. Similarly, you differentiate. The same as this. On differentiating this, dG equal to dH minus ds minus s dt. Okay. Therefore, substitute now dH. Substitute this one. dH equal to this here. Therefore, dTs will cancel, and then you get dDp minus s dt. Okay. Next, A equal to E minus ds. Very simple. Very simple. Same. Okay. Then on differentiating this expression, dA equal to dE minus T ds minus s dt, and you know dE, substitute this one. Okay. Then dA equal to minus PdV minus s dt. Now you obtain 1, 2, 3, 4. Remember 1, 2, this 1, 3, 4 and 5 equations are very important for obtaining the Maxwell's relationship. Okay, let us write first. As I said, these 4 equations are important. First, we write this equation. D is equal to dds minus pdv. Okay. Now V constant. Let us take V constant. Therefore, dV. Since V is constant, there is no change in dV. dV equal to 0. Therefore, dou E by dou S. This is 0. Okay. V is constant. Therefore, dou E by dou S, partial differentiation and constant volume equal to T. Okay. Similarly, now take S equal to constant. V equal to constant, S equal to constant, ds equal to 0. Therefore, dou E by dou V and constant entropy equal to minus PV. Okay. So you call this as 6 and 7. Differentiate. Now differentiate this equation with respect to volume, because already it is differentiated with respect to entropy. Therefore, dou E by dou square E by dou S, and differentiating with respect to volume, therefore dou V equal to dou T by dou V. Okay, plus sign, therefore dou T by dou V at constant entropy. Okay, now differentiating this expression 7 with respect to this is dou V, therefore dou S. Differentiating with respect to S. Here dou S, so differentiating with respect to volume. Here differentiating with respect to entropy. Therefore, dou square E by dou V dou S equal to minus dou P by dou S at constant volume, because here constant volume only with respect to entropy. Therefore, constant volume. Okay. So we have now these two. See, dou square, the left hand sides are equal for these two equations. Dou square E by dou S V. This is dou S by equal only. Therefore, therefore minus dou P by dou S at constant volume equal to dou T by dou V constant entropy. Okay, this is the first Maxwell relation. For this one, there are four equations. Then you can derive that. For dE we have derived, dH you derive another Maxwell relation. Similarly, you will get, and there are four sets of equations. There are four equations called Maxwell relationship. Okay. Similarly, let us take now dH, this expression. Okay, dH equal to dTs plus dDt. Similarly, S constant here, S constant, and therefore ds equal to 0. Therefore, same expression. So it is very simple. One you can do it. You can do the entire thing. It will be very easy. Therefore, S constant. Therefore, ds equal to 0. Dou H by dou P equal to constant entropy equal to V. Okay. Similarly, and differentiating with respect to this is dou H by dou P. Then we are varying entropy also. Therefore, dou square H by dou P and dou S. There are differentiating with respect to entropy. Then dou V by dou S at constant pressure. Similarly, P constant in this S constant and the next P constant. Therefore, dP equal to 0. dP equal to 0. Therefore, dou H by dou S equal to T at constant pressure. Similarly, differentiating this equation with respect to what is with respect to dou P, with respect to dou P. Here, P is the difference in this expression P. Therefore, dou square H by dou S dou P equal to dou T by dou P at constant entropy. Okay. Therefore, the left hand side, you see, the left hand sides are equal. Therefore, the right hand sides are equal. For this you have obtained the relationship now. Similarly, you obtain the relationship for dG. dG equal to, so you keep first P constant, you will get one expression, and T constant, another expression, and then double derivative, take double derivative, you will get this Maxwell relationship. Similarly, for dA minus P dV minus S dt, you will get this Maxwell relationship. Therefore, there are four equations A, B, C, D. Equations A, okay, B, and C, and D are called Maxwell relationship. Okay, what are the uses of Maxwell relationship? Maxwell relationships are very useful for calculating, for determining the entropy change. For example, the entropy change cannot be measured. The disorder cannot be measured, but it can be calculated. The entropy change with respect to, it can be calculated from measurable quantity. What are measurable quantities? For example, volume, change in volume can be measured. Change in temperature can be measured. Change in heat can be measured. Therefore, for example, here the change in entropy cannot be determined, but using Maxwell's relationship, you know this term, right hand side you know. Therefore, you know that entropy change with respect to pressure. Therefore, entropy change cannot be measured, but it can be measured from measurable quantities using Maxwell relationship. These are the important usefulness of Maxwell relations. If you know one change in property, thermodynamic property, you can calculate the change in thermodynamic property of another quantity. Okay. Similarly, you see this is another important. Dou E by dou S be equal to T. Here also you see dou H by this is dou E. This is the expression for obtained for dH. Dou H by dou S. So these are equal. Therefore, dou H by dou S P equal to dou H by dou S P. They are equal. This and this are equal. Similarly, you will get another three sets. Another three sets. They are also called Maxwell relations. These are very useful for calculating the various unknown thermodynamic parameters, changes in unknown parameters from the known parameters. Okay, thank you for watching. These are very much useful for GATE examination, CSIR and IIT exam, even in NEET also they may ask. Please, it is simple, a mathematical derivation. It is a simple mathematical derivation. It is the steps are repeating. The steps are repeating. So if you remember one step, then you can solve the entire thing on the board by yourself. Thank you for watching.